Hi, in today's lesson, we are going to solve the Cambridge IGCSE chemistry paper. Subject code for this paper is 0620 and variant 42. And it is the latest paper from October November 2025 series, right? So let's go over the paper. Students, as you will be knowing, usually the first question they are asking you regarding the structure of solid, liquid, or gases. So as you can see, it's a very common question. So firstly, you have to talk about the arrangement of particle in solid, liquid, and gases. As you will be knowing, among the solid, the attraction between particle is more. If you come to liquid, the particles are able to slide over each other as the force of attraction are weaker as compared to solid. And for gases, the particles are moving randomly in all different directions. So the arrangement of particles for solid is uniform. Okay, so the particle arrangement for a solid is uniform. The structure of a solid is uniform throughout. And the motion of the particle in a solid, because the particle in a solid cannot move, so we can just say they vibrate. So they are able to show only vibrational motion, or they can just vibrate. As regarding the particle separation, you can see for a solid, the particles are, because the particles in a solid are touching each other, because the volume of the solid doesn't change. So similarly, the particle in liquid also, they are just able to slide over each other, but still they are touching, like they are not no more gaps, so they are just touching. And for the particle arrangement, you can see in a solid the particles are having fixed position, but for a liquid it's not a fixed position, so like we can say they are randomly arranged. Now the particle motion in a liquid also, it is they are able to move little bit over each other, so we can say, but there is no like there is only random motion. Okay, the particle motion is not in a particular area, it's a random motion. Okay, now next, when you are talking about gases, the particles are further apart, because the particles are having very weak force of attraction, so we can say the particles are further apart. And the motion already given, it's random, and even the particle arrangement is random. Okay, now let's move on to the next topic. The next topic is regarding the physical changes. We have to name them. It's very easy topic, even students, you have done this topic even in grade 7. So when a solid is turning into a liquid, we call this change as melting, right? And gas into liquid, this is called condensation. And solid into aqueous, like for example, we are having solid salt and we dissolve in water, so this is called dissolving. Usually you would see in IGCSE chemistry paper, the first question is easy, and as we move to the next question, the difficult level of the question will gradually increase. Okay. Now next question is, even from the first chapter itself, you would have studied about the process of diffusion. That in the diffusion, what happened? The particles are moving randomly, right? Okay. So first question they are asking, in terms of particle, why gas diffuse? So because of why the particle of gases are able to diffuse, because of the random motion of the gas particles. Okay. All right. Okay. What determine the relative rate of diffusion at a constant temperature? Students, you will be knowing there is a famous experiment regarding the diffusion. You would see it's given even in your textbook. So on one side there is a cotton wool soaked in NH3, and one side there is a cotton wool soaked in HCl. So there is a white cloud or white ring is forming near the end of HCl, right? There is a white ring is formed or white cloud is formed near the HCl, because the NH3 particles are lighter, so they are traveling to a greater extent. Okay, so they travel a greater distance, and HCl particles are the HCl particles are heavier, so they travel less distance, right? So same idea you can use over here. So and the like what determines the relative rate of diffusion? So you can say the relative molecular mass. The relative molecular mass, or we can say the MR. Okay, so the movement of particle is determined by the MR. Lower the molar mass, more movement will be for the particle, or more the relative rate of diffusion will be faster. Okay, now next question is about the gases oxide of nitrogen. They are atmospheric pollutants. One adverse effect of oxide of nitrogen in the form is the formation of acid rain. Usually, nitrogen oxide and sulfur dioxides, they are responsible for the phenomenon called acid rain. So now we have to talk about any other adverse effects of the oxide of nitrogen. All right, so there is because you can see when you inhale them, they are having they will cause respiratory problems, because they are we can say choking, because if you inhale nitrogen dioxide, there is mucus is having water inside it. Even in the lung capillaries, water is there. So when you inhale nitrogen dioxide, it's going to be toxic, so we can say it may cause respiratory problems. Okay, like it can cause choking. The next effect, you would have heard about photochemical smoke. The photochemical smoke is formed when nitrogen oxides combine with unburned hydrocarbon. Okay, so nitrogen oxide, when they burn, they are combining with unburned hydrocarbon, it will form photochemical smoke, and this phenomenon is very adverse in like the industrial cities. You would have heard in the news. Okay, now let's move on to the next question. So in this question is about the environmental effect of nitrogen oxide on the environment. So you have to name a toxic gas which is produced by incomplete combustion of a fuel, like hydrocarbon fuel, like petrol. For example, you are burning petrol. Student, you would have studied in organic chemistry. When a fuel is burned in excess of oxygen, the products are going to be carbon dioxide, water. Okay, so when you are burning some fuel in excess of oxygen, the products are going to be carbon dioxide and water. And when there is a lack of oxygen, that is called incomplete combustion. So in the lack of oxygen, the products are going to be carbon monoxide and water, right? And you will be knowing the dangerous effect of carbon monoxide is because it can cause lack of oxygen in the body cell, because it is combining with hemoglobin in the red blood cells, and the red blood cells are unable to carry oxygen. So that toxic gas will be carbon monoxide. Okay. Name the two non-toxic gases formed in the catalytic converter. Okay, so students, there is an equation which is happening in the catalytic converter. Actually, catalytic converters, because in the gas engines or the automobile engine, there is the inside the temperature, the internal combustion engine, the internal temperature is very high. So due to that temperature, what happens? There is a formation of nitrogen oxide, and as you can see in the first question, like this question, carbon monoxide. So the catalytic converter or exhaust system of the cars, they are converting nitrogen monoxide and carbon monoxide into nitrogen gas and carbon dioxide. So this is the equation. Okay, so catalytic converter, what is the basic function of them? We are usually using platinum coating in the catalytic converters. So nitrogen oxide and carbon monoxide are converted into nitrogen and carbon dioxide gases. So these two products are formed by the catalytic converter, so you have to name them. So first one is nitrogen gas, and the second product is carbon dioxide gas. All right. Okay, so with this question we are ending the first question. Now let's move on to the next one. I hope everything is clear. All right, now let's move on to the next question. Student, next question is also very common. You would have seen in IGCSE exam, mostly it's the extraction of metals. Either it's aluminium most of the time, or iron. Okay, so this question is regarding the extraction of iron from the ore, right? And iron ore, you will be knowing the common iron ore, the one we use is hematite. So this is the ore of iron from where we are extracting iron, right? All right, so the iron compound is the main iron ore in the blast furnace is iron 3 oxide. State the name of the main ore used in the blast furnace. So as I said, the ores of iron name is hematite. And similarly, for extraction of aluminium, the ore is called bauxite. Okay, for aluminium. So now question arises. State how the main source of heat is provided in the blast furnace, right? So actually you will be remembering in the blast furnace there are 3 raw materials we are adding, right? Okay, so the raw materials you will be remembering. So we are adding from the top of the blast furnace, we are adding the raw materials are the first one is coke or powdered carbon. Coke or powdered carbon. Second is limestone, you will be knowing. So these are the 3 raw materials, and the last one is obviously the iron ore or hematite ore. Okay, so these are the 3 raw materials which we are adding. So out of these 3 raw material, the raw material which is responsible for maintaining high temperature inside the blast furnace is coke or carbon, right? So we can say for this one we can say by burning of coke, by burning of carbon, or you can say coke. The powdered carbon is called coke. So now next question, we have to name the gaseous reducing agent which you use in the blast furnace. Students, you will be knowing in the first step of the equation. Let me write for you, then you can recall it. Actually, if you go over the equation which are the reaction which are taking place inside the blast furnace, firstly what is happening? In the first step, what will happen? Carbon will be starting burning to form carbon dioxide. And this reaction produces a very high temperature as we are discussing over here, right, in this question. For step 2, what will happen? Because we are adding carbon in a large excess, so what will happen? Carbon dioxide will react with more carbon to form carbon monoxide, right? So actually this is the reducing agent, okay, and which is created in the second step. So the name of this reducing agent is carbon monoxide. Carbon monoxide. So carbon monoxide is acting as a reducing agent. Okay. Now in the next question, now they are asking you about the third equation. Okay. So this carbon monoxide is going to reduce the iron ore into iron, right? So let me write the equation for you. So actually what will happen, the iron 3 oxide ore will react with carbon monoxide. Now you can see iron oxide is going to lose oxygen, or it is getting reduced. So what will happen, iron oxide will turn into iron, molten iron. So you can put 2 over here. And now as you can see, there are 3 oxygen with iron 3 oxides. So we have to take 3 carbon monoxide molecules, and then to balance it, then it will get you 3 CO2. So the role of carbon monoxide, you can understand, the carbon monoxide is getting oxidized itself, right? So how about iron 3 oxide? It is getting reduced. So due to this reason, carbon monoxide is acting as a reducing agent, because reducing agent is the substance that is reducing other substance and getting oxidized itself, right? So we have to know these 3 steps, right? Okay, now next question is the main impurity in the iron ore. You will be knowing it's silicon dioxide or the inorganic sand. Okay, the formula of silicon dioxide is SiO2. Okay, so silicon dioxide is called inorganic sand, and the formula of this one is silicon SiO2. And if this silica impurity has to be removed from the iron ore, because if you are not removing it from the molten iron, this silica impurity makes iron brittle. Okay, so now they are asking you 2 simple equations to show the role of limestone in the removal of silicon dioxide. As I told you before, the raw materials inside the blast furnace are 3. We are adding coke or carbon, and then we are adding iron ore, and then we were adding limestone. You will be knowing the limestone formula is CaCO3, calcium carbonate. So in the first step, what is going to happen? The CaCO3 will undergo thermal decomposition. So it will form calcium oxide and carbon dioxide. This is called thermal decomposition, this reaction. Okay, so in some exam they may ask you the type of reaction will be thermal decomposition, or here the type of reaction is not required. Okay, so this is thermal decomposition. Now next step, what will happen, the silica impurity is going to react with calcium oxide. I can write for you here. So calcium oxide plus silicon dioxide, the silica impurity is going to react to form commonly it's called slag, and chemically speaking we say calcium silicate. Okay, so this is called calcium silicate, or we can say commonly it's called slag. Now they may ask you, in some paper they are asking you the type of this reaction. You will be knowing calcium oxide is a basic oxide, and silicon dioxide is, because it's a non-metal oxide, so it's an acidic oxide. So the type of this reaction will be neutralization. Okay, reaction number 2 is going to be neutralization. So sometimes they may ask you the type of reaction. So this type of reaction is called neutralization. I hope everything is clear. All right. So if they ask you the type of reaction, the first reaction number 1 is said to be thermal decomposition, and second reaction is said to be neutralization, because calcium oxide is a basic oxide and silicon dioxide is an acidic oxide. So whenever acid and base react together, we say neutralization, right? Okay, now let's move to the next question. Even this question is very common. Sometimes actually they will give you, now you can see A, B, C and D. You can see they are all having same symbol, and you will be knowing like actually these are having, we call a term called isotope. Okay, so they are the isotopes of iron, right? So we have to say, in simple term, they are asking us to define what do you mean by isotopes. Okay, and always you have to say in terms of subatomic particles. Okay, so we can say these are atoms of the same element, and in all of them the element is iron, right? This is the basic requirement, the element should be same. So we can say atoms of the same element having same number of protons even the number of electron will be also same, right? So same number of proton, and that electron you can say in the bracket, and electrons, but different number of neutrons. So the atoms of the same element which are having same number of protons and different number of neutron, they are called isotopes. Okay, this is very common question in the past papers. And for all of them, the atomic number is going to be same. You can see from the periodic table, for all of them, the atomic number is 26. All right, because atomic number mean the element is same. So element is same, but what is different? The mass number is different, or we can say the mass number is different to be precisely because the number of neutron is different for these atoms. Now let's move on to the next question. Students, this question also very common in the past paper. So as I told you before, the atomic number of iron you can see from the periodic table is 26. So you have to work out the number of proton, neutron and electron. You can see because the small number is called the atomic number. So that number represents the number of protons. So it's having 26 proton for iron, 2 plus. For the neutron number, what you can do? We can just subtract, like for the number of neutron, what we can do? The mass number minus the atomic number. So for the neutron number, what you can do? 54 minus 26. Okay, so when you subtract 54 and 26, it's going to be 28. So over here you will write 28. So the number of neutron is 28 for this. And the electron number, one thing remember, when there is a positive charge, it means there is a loss of electron. So, and it's having 2 plus charge, so it means you have to remove 2 electrons from there, right? Because a neutral atom is having equal number of proton and electron, but when there is a positive charge, it means the number of electron is going to be less. So you have to just decrease 2 electrons from there, so it will become 24 electron for this. And for Fe3 plus, the number of electron is going to be one more less, okay, because it was for Fe2 plus it was 24 electron. So if it is Fe3 plus, the number of electron are going to be 23, and number of proton will be same because the element is same. And for the number of neutron, what you can do now for this one, we have to subtract 58 minus 26, so it's going to be 32. So the number of neutron for Fe 58 is going to be 32, right? So we have to fill this table. Okay, so whenever you are counting the number of proton, what you can say, the atomic number is the number of proton. You can see both of them are having same number of protons. For number of neutron, what we can do, we can subtract mass number from the atomic number like that, and even for this isotope we did like that. And the electron number depending upon the charge. If it is a charge element, ion, so what you can do, just look at the charge and these many electrons, you have to decrease them, right? Now next question, we have to give a chemical test for Fe2 plus ion. So there are there are two different chemical tests available. You can go with sodium hydroxide solution, or you can add aqueous ammonia. So what is the test? We can add aqueous sodium hydroxide, NaOH, sodium hydroxide, and what you will see a green precipitate. Okay, green precipitate forms, which is insoluble in excess, because it doesn't dissolve in excess. Okay, so green precipitate form insoluble in excess, and that if you want, you can write on the surface it turns brown because of the oxidation of Fe2 plus ion by the atmospheric oxygen. It will turn brown, right? Student, now next thing we have to say, What is an oxidizing agent? Remember, there was a question regarding the role of carbon monoxide in that reaction during the extraction of iron. So oxidizing agent is just opposite of reducing agent. So oxidizing agent is a substance that oxidizes other substance and gets reduced itself. So oxidizing agent is a substance that oxidizes other substance or species, we can say, and gets reduced itself. Alright, so oxidizing agent is a species or it's a substance which is oxidizing another substance and getting reduced itself, right? Okay, for the next question, they're asking us, we have to explain why the conversion of Fe2 plus ion to Fe3 plus ion is described as an oxidation, right? So if you want to convert Fe2 plus ion to Fe3 plus ion, so we can say, I can show you the equation, then we can write the answer. So Fe2 plus, if you want to change into Fe3 plus, how can you do it? You have to lose one electron, right? So when one electron is lost, Fe2 plus will get converted into Fe3 plus. So the answer for this one is by the loss of electron. By the loss of electron. Okay, so Fe2 plus is getting converted into Fe3 plus by the loss of electron, or you can say one electron. Okay, now next question, the third one. The oxidizing agent for the conversion of Fe2 plus to Fe3 plus is usually potassium manganate, right? So we have to state one condition which is required for the oxidation to take place. This thing we have studied in organic chemistry. You remember the reagent for the oxidation of alcohol is the same. That is called acidified potassium manganate 7, right? So the condition is it should be acidified. Or we can say, to be precise, the acid is H2SO4 or sulfuric acid. So for the oxidation of alcohol or even for the oxidation of some ions into the higher valency, we need acidified KMnO4, right? Or we can say potassium manganate 7. Okay. Now, students, for the next question, we have to just see the iodide ions are reducing Fe3 plus ion to Fe2 plus ion. Okay, I can explain you this way. See, actually they mean to say Fe3 plus ion are undergoing reduction, right? Fe3 plus ion are going to Fe2 plus. So reduction means you will be having one electron, right? Because there will be gain of one electron, so Fe3 plus will get converted into Fe2 plus. This is a reduction. And for the oxidation half equation, what we can do, iodide ion are undergoing oxidation, okay? And as you will be knowing, the iodine and all halogens are diatomic, right? So whenever you want to lose electron, you have to make I2. So if you want to make I2, you have to take 2 iodide ion and there will be loss of 2 electron. And to balance the equation, we have to multiply the first equation by 2, right? And the overall equation for this reaction is going to be 2Fe3 plus 2I minus, because electron will get cancelled. These are the two half equations, we call them ionic half equations. One is for reduction and one is for oxidation. And the overall equation will be like that, the one I'm writing for you. So Fe3 plus will undergo reduction and iodide ions are undergoing oxidation, right? So what is the identity of the other product which is formed? So Fe3 plus ion got reduced. So iodide ion got oxidized and they made iron 2 plus. Okay. So the identity of the other and you can see Fe3 plus got reduced. So the other product is iodine. So for this one, iodide ion will change into iodine, or you can say I2. because Fe3 plus ion, you can see they undergo reduction. So iodide ion has to undergo oxidation, and when iodide ion undergoes oxidation, it's going to be I2, right? I hope it's very clear. So with this one, we have completed question number 2. Now let's move on to the question number 3. Student, you will be knowing this question is regarding the preparation of salt, right? So, and to be precise, the preparation of insoluble salt. And usually they give this information along with the question. So firstly, we have to complete the equation and put the state symbol. And they told you already the salt is insoluble. So insoluble salt, the state symbol is going to be solid. So over here you have to put solid. And it's a double displacement reaction. So the other compound is going to be, you can see sodium ions are there and chloride ions are there. So it will react to make sodium chloride, NaCl. And state symbol is going to be AQ because sodium chloride is soluble, and you have to put 2 here to balance the charges. Okay, so the equation is like that. I hope it's clear, right? Okay, now students, what you have to do, you have to work out the mass of barium chloride. So for working out the mass of barium chloride, BaCl2, you need to see the periodic table. Okay, so you have to see barium and 2 chlorine. For barium, we can see from the periodic table. Barium, you can see over here is 137, right? So the mass number of barium is 137. So 137 for barium plus chlorine is, you have to first work out the molar mass. Okay, chlorine, you will be knowing 35.5 for 1 chlorine. So multiply by 2 because there are 2 chlorine. Okay, so the molar mass of barium chloride is going to be, when you add them, let me do it in calculator. So 71 plus 137. So it's going to be 208, and the unit will be grams per mole. Okay, this is the MR. Now in the step 1, you can see they have told us the moles, right? They told you moles. So now what you have to work out, you have to work out the mass. Okay, so to work out the mass from the mole, the formula is this one. You will be knowing mole is equal to mass over molar mass. So if you want to work out mass is equal to number of moles multiplied by the molar mass, or MR. So the number of mole they have given you over here, they were 0.10. So 0.10 multiplied by 208. So when you multiply it, it's going to be 20.8 grams. So 20.8 grams. So whenever you want to find a mass, you need to first of all find the MR. Okay, so MR you can find from the periodic table. Barium is 137, and for chlorine it's 35.5. But because there are 2 chlorine atoms, so 35.5 multiplied by 2. Right? Okay, like this one. Okay, now in the next question they have told you the concentration of sodium sulfate. Okay, it's given in mole per decimeter cube. You have to work out the volume in centimeter cube of this solution added in step 2, which contain 0.1 moles of Na2SO4, right? Okay, so for this one, actually what you have to do, first of all you have to you can because it's connected with the previous question. So we are having sodium sulfate 0.10, right? So you have to multiply 0.10 divided by 1.25 into 1000. Okay, so when you do it, so it's going to, because this one we do to you will be, let me tell you one thing why you are doing so. Okay, so actually they told you this is the concentration, all right, and these are the moles, and you will be knowing there is a formula which is having n is equal to, you will be knowing this formula, n is equal to c into v. So if you want to work out v is going to be n over c, right? So just apply this formula, and when you apply this formula, your answer is going to be, let me do it in step for you. So when you do it, so your answer is going to be in dm cube, right? So when you your answer in dm cube, so 0.10 over 1.25 is going to give you 0.08 dm cube. So when you want to convert, because they want centimeter cube, so just multiply by 1000, because you will be knowing 1 decimeter cube is equal to 1000 centimeter cube. So just multiply by 1000. So when you multiply by 1000, it's going to be 80 centimeter cube. So you will write this answer over here. Okay, so the volume of sodium sulfate solution is 80 centimeter cube. Now, in the next question, they are asking you about the color of the solid form. They are asking you the color of barium sulfate. Students, you will be knowing, if there is a precipitate of a non-transient metal compound, and non-transient metal, you know, they cannot show colors. So the color of this precipitate is going to be white precipitate. So it's going to be white PPT or precipitate. Okay. Now next question. You know, the mixture is filtered in step 3. They are talking about this step. So actually, when you want to make an insoluble salt, first of all, you are going to mix the two soluble salt solution with each other. After that, you are going to filter them, right? So state the general term used to given to a solid left over in the filter paper. To be precise, you know, we say residue. So when you are doing filtration, you are putting filter paper in the funnel. So residue is actually the solid particle which are inside the filter paper, okay, which are not moving through the filter paper. This is residue. Okay, and the solution which is going through the filter paper, that is called filtrate. Okay, the solution which passes through, this is called as filtrate. We have to remember it, okay, because in some paper they ask you. So it's called residue. Okay, now let's move on to the next one. The actual mass of dry barium sulfate collected in step 4 is greater than the expected value, right? This is because students are not doing any additional step between step 3 and 4, right? Actually, whatever, usually when you want to make some compound from a reaction, usually mass produced will be less. But in this case, the mass the student is obtaining is bit more or greater. Actually, if you remember, in when you are doing insoluble salt, what we do, if you remember, after you filter it, you cannot directly dry it. You remember, one step is missing. That step they're asking you. So if you remember, after we filter out the insoluble salt, we have to wash with distilled water, right? Because if you are not washing with distilled water, what is the problem? There will be some soluble salt, like you can say sodium chloride, soluble salt. So these will be impurities present in the insoluble salt. So due to those impurities, what will happen? The mass of the crystal produced will be greater. You know, you will get greater mass. So after you filter out the precipitate, next what you have to do? We have to wash it and then dry it, right? Okay. So you have to wash the residue, okay? So what do you have to do? Next step, we have to rinse or wash the residue with distilled water. All right. And why the mass of the crystal is greater? You will say because it may, I told you already, it may have some NaCl, okay, this one, because the residue contains some sodium chloride. Okay, so if you don't wash with distilled water, there will be some sodium chloride solid which will be left over, right? And due to this solid, the mass of the insoluble salt which is produced will be greater, right? Okay. Now next question, they're asking you the name of this method of salt preparation. Student, very common question. So as you know, the formation of insoluble salt you can understand from the equation, because there is a formation of a precipitate, so this is called precipitation reaction. Okay, so the name of this method is called precipitation. Right? Okay. Now next question, state the name of a different barium salt that can be used in place of barium chloride. Like you can say any barium salt which can be used in place of barium chloride. Barium chloride is a soluble salt, and you remember in the solubility rule we studied all nitrates are soluble, so you can use barium nitrate. Okay, barium nitrate. And students, sometimes if some of you may write the formula of barium nitrate. The formula of barium nitrate is BaNO3 bracket 2. But problem is, because they are asking you to name the salt, so here if you write the formula, although it's correct, but marks will not be given because they want you to write the name of the salt. Okay, so it will be barium nitrate. Now now they want you to write name of any other salt other than sodium sulfate. Okay, this is another soluble salt, so they want you to write any soluble salt which is soluble but it's not sodium sulfate. Again you can make use of the solubility rule. You remember group 1 all salts are soluble, so what you can do, in place of sodium sulfate we can use potassium sulfate, right? Okay, or even we can use lithium sulfate. So you can use potassium sulfate because all group 1 compounds are soluble. Potassium sulfate we can use, or even student we can use any other sulfate like ammonia. You remember all ammonium salts are soluble, so we can use even ammonium sulfate. Okay, and barium salt that can be made by this method. So when you do this one, it will be and any other bariums, but the salt which will be insoluble, right? So you have to use barium carbon. Like if you want to make any other insoluble salt, so group 2 sulfates are insoluble and group 2 carbonates although not very soluble, so we can say barium carbonate. Because you please remember it, group 2 sulfates and carbonates are not very soluble, so these are insoluble salt and these we can make by precipitation method. With this one we are done with question number 3. Now let's move on to the next question number 4. This question is about the acid, alkalis, these kind of questions are there. So one you can see they have given you 2 acids. One is nitric acid and the other one is sulfuric acid, right? They are strong acids, and you can see ethanoic acid which is a weak acid, right? Okay, 1 mole of each of the acid is added separately to 1000 centimeter cube of distilled water to form a dilute solution. All of these acids are they dissociate in distilled water. State the formula of the common cation which is produced by all of these 3 acids when they dissociate in water. You will be knowing acid is the substance that ionizes or dissociates in water. Better to say the word dissociate, that dissociates in water to form H plus sign. Okay, so acids are forming H plus sign. You will be knowing whenever acid dissociate in water, it will form H plus sign, and bases or alkalis, when they dissociate in water, they will form hydroxide ion, right? You have to remember this one. Okay, so acid ionize or dissociate in water to form H plus ion, and the bases or alkalis they dissociate to form hydroxide ion. Okay, explain in terms of dissociation why nitric acid is a strong acid. Okay, so a strong acid, it dissociate completely, so you can say it completely dissociates. And how about the ethanoic acid? It will dissociate partially. partially dissociated. So, okay, so the term weak acid and strong acid depends upon the dissociation, the relative dissociation of the acid. So if there is a complete dissociation, it will be a strong acid, and if there is a partial dissociation, it will be the weak acid. Okay, now we have to say which of these acids will be having the highest pH. Student, you will be knowing the pH number of acids are usually going from 0 up to 6.9. So these are pH numbers of acid, right? And you will be knowing the weaker the stronger the acid, the smaller pH it will be having. Okay, the strongest acid will be having a pH of 0, right? And the weakest one will be having a pH of 6.9. So it means among these three acids, they told you already, ethanoic acid is a weak acid, right? So ethanoic acid pH will be higher because it will be something like 4 or 3, like that. Okay, so among these three acids, ethanoic acid will have the highest pH, CH3COOH, or you can say ethanoic acid. Okay, you can name it or you can write the formula. Ethanoic acid. Okay, next question, and they're asking you, state the color of thymophenolphthalein in all of these acids. You will be knowing thymophenolphthalein is colorless in all of the acids. Okay, so it's colorless. Okay, now next question, you have to write the formula of the ions or the anion which is formed when sulfuric acid dissociates in water, right? So I can write for you the equation for the dissociation of sulfuric acid. Okay, and you know sulfuric acid is a diprotic acid, so it will ionize to form 2H plus ion and 1 sulfate ion. Okay, so the anion produced is sulfate ion for this. And for ethanoic acid, the equation I can write for you here. So when ethanoic acid ionizes in or dissociates in water, it will form CH3COO minus and H plus ion. Okay, so the anion over here is CH3COO minus. All right. Now let's move on to the next question. This question is regarding the electrolysis topic. Okay, so name the two gaseous products which are formed by the electrolysis of dilute sulfuric acid using inert electrode. You know, when sulfuric acid is ionized in water, so you know, for electrolysis question we can write first what are the ions present for sulfuric acid, for dilute H2S4. So you can see, as you can see, I wrote one equation for you. So when sulfuric acid dissociates, it will get you hydrogen ion and sulfate ion. Okay, you can see from there. Okay, that's why I wrote equation for you. So it will give you hydrogen ion and sulfate ion, right? And because aqueous solution, so there will be two ions coming from water. We can say H plus ion, that is common ion, H plus ion, and then hydroxide ion. Because an aqueous solution, so there will be OH ion and H plus ion, they are coming from water, right? Okay, so you can see when these ions are there, so two gaseous product form. Okay, so one will be at cathode and then one will be at anode. You will be knowing the equation at cathode. Hydrogen ion will be going at cathode, and hydrogen ion will gain 2 electron and it will form hydrogen gas, right? So the name of the one product is hydrogen at cathode. You can just say hydrogen, and you can see among sulfate ion and OH ion, the hydroxide ion will go to anode. Okay, that equation I can write for you here down. So the anode equation is going to be, you will be remembering in electrolysis chapter we have studied it. So 4H minus give you 2H2O plus O2 plus 4E minus, right? So the product at anode is going to be oxygen. It will be oxygen, right? You have to remember this one. Okay, now next question is, when calcium reacts with ethanoic acid, you have to tell the name of the salt, right? And as you know, this ion, the ion which I wrote for you on the top, this is called ethanoate ion. So basically, when ethanoic acid react with some metal, it's forming salt which are organic salt, and their name ends in ethanoate, right? So because calcium is reacting, so you can say the name of the salt is going to be calcium ethanoate. Calcium ethanoate, right? Okay. I can quickly write an equation for you which will clarify your doubts. Okay, so the reaction equation will be the one which I'm writing for you now. So when calcium react with ethanoic acid, it's CH3COOH. So you will get a salt. I can explain you this way. Ethanoate ion is actually -1, right? And calcium is +2. So the formula of the salt is going to be CH3COO. You have to put a bracket because calcium is 2+, put 2 here, and Ca outside the bracket, plus H2. So to balance it, we can put 2 over here. So you know, when metal react with an acid, you will get salt and you will get hydrogen gas. Alright, so the name of this salt is calcium ethanoate. Alright, now next thing we have to say, we have to define the term base. You can see, you know, in terms of the Lowry-Bronsted theory, base is a proton acceptor, we can say, okay? So proton acceptor. And for acid, the definition of an acid is a proton donor, right? The opposite of base, right? So now next thing is aluminum hydroxide is not an alkali. As you will be knowing, the definition of an alkali is water soluble base is called alkali. So if they ask you what is an alkali, so alkali is an water soluble base, right? So if a base is soluble in water or it dissolves in water, it is called an alkali. Now as they said themselves that AlOH3 is not an alkali, so what does it mean? It means it is insoluble. Okay, so this is insoluble in water. All right. Now they can. Now next question is, they name another compound which forms aluminium nitrate when react with nitric acid. Okay, so if you want to make aluminium nitrate, you can either react aluminium hydroxide or you can react aluminium oxide, Al2O3. Okay. Aluminium oxide. So either we can use aluminium hydroxide or we can use aluminium oxide. The formula of aluminium oxide is Al2O3, but over here they won't name, right? So we have to say aluminium oxide. All right. Now, students, in the next question, they are asking us to work out the oxidation number, right? Okay. So I will quickly do it for you. You know, when you have this kind of question, what you can do, you can, now you can see, they already told you the oxidation number of Al3+, right? So you have to determine the oxidation number of nitrate ion in aluminium nitrate. So as I told you already, see, Al is +3 and you will be knowing NO3 is -1. Okay, and how you know it's -1? Because you know when you write a formula, this is a crisscross arrangement. So this number goes there and 1 usually we don't write. So it will be Al NO3 and bracket 3, right? So this 3 is the oxidation number or valency of aluminium. Okay, they told you already. Al is 3+, and we know nitrate is -1, right? So by using this information, now we can work out for nitrogen. Okay, now let me do it for you. So for NO3 1-, it's -1 charge, right? So when it's NO3 is -1, what you can do? See, in place of nitrogen, what you can do? You can do this way. In place of nitrogen, we have to work out the oxidation number of nitrogen, right? Okay, so what do you do? In place of nitrogen, you can put X because you want to calculate. And oxygen, they told you already, one oxygen is -2, right? So -2, you can multiply by 3, right? Because there are 3 nitrogen, 3 oxygen, so -2 into 3 is equal to, because NO3 is -1, so it is equal to -1, right? So now you can just simplify it. So it's going to be X, -2 into 3 will be -6 is equal to -1. So X is equal to -1 plus 6. So it is equal to +5. Okay, so the oxidation number of nitrogen over here is +5. Okay, so how can you work out the oxidation number? What you can do, just in place of that element, because we are not knowing for nitrogen, so in place of nitrogen we just put X and just simplify this one. And oxygen is -2, and there are 3 oxygen in nitrate ion, so -2 into 3 is equal to -1. Okay, so by this way, by solving like algebraic equation like just like that one, you can solve it and you will get the oxidation number of nitrogen in the nitrate. Okay, students, now we'll go for the last question. The last question, or question number 5, is usually about organic chemistry, right? Okay, now they're asking you 2 general characteristics of a homologous series of alkane. Okay, so first thing is, you will be knowing the general formula of an alkane is CnH2n plus 2. Okay, so you can talk about the general formula. Okay, so they have a general formula Cn, n is a number of atoms, okay, 2H2n plus 2, and for an alkene it's going to be CnH2n. You will be knowing now, for an alkene it is CnH2n, because there is a double bond, CnH2n, and for an alkane there are 2 hydrogen atoms, so it's going to be CnH2n plus 2. And secondly, other than, but the properties they have already given, you cannot say, you cannot say about functional group. Okay, so second property is you can talk about the difference between the 2 adjacent member. Okay, so the 2 adjacent member differ by CH2 group. I can explain you on this side. Okay, let me explain you. Student, you will be knowing methane. The formula of methane is CH4, and the formula of the next hydrocarbon, ethane, is CnH2n plus 2. Okay, is C2H6. And for propane, the formula is going to be C3. H will be double plus 2, so 6 plus 2, 8, C3H8. Now you can see, if you subtract the 2 adjacent members, there is a difference of 1 carbon and 2 hydrogen. You can see now, there are 4 hydrogen in methane and there are 6 hydrogen in ethane. So there is a difference of 2 hydrogen atom and there is a difference of 1 carbon. Even between ethane and propane, there is a difference of CH2 group. So the adjacent member of a homologous series are differing by CH2 group, right? Okay, now next thing, state the trend in the boiling temperature of alkanes as the carbon length increases. Students, you will be knowing when the number of carbon increase in an organic compound, or even when the number of electron increases in a covalent molecule, the boiling point increases. Okay, it increases, or we can say it's directly proportional. Because the intermolecular forces will get stronger, so the boiling point will keep on increasing. Okay, now nextly, you have to name another physical property of an alkane that shows a regular trend, right? Okay, so other than melting point and boiling point, okay, you have to describe this trend as the number of carbon increases, right? So you can say any physical property, the property you can measure. So we cannot say melting point, we cannot say boiling point, but we can talk about density, right? Okay, so what is the density? What is the description? As the length of the carbon chain increases, the density increases, directly proportional. Okay, density also increases. Similarly, melting point will increase, boiling point will also increase. Okay. Now next question is they are asking you why the alkanes are said to be unsaturated. Like you can say ethane, ethane the displayed formula of ethane is like this, right? So for we call them saturated because they are having carbon to carbon single bonds only. Okay. They contain carbon to carbon single bond only. Okay, so any hydrocarbon which is having carbon to carbon single bond, that is called saturated. Okay, I hope this is clear. So now let's go to the next part. Student, in this question they're asking you, it's about propane. When propane undergoes substitution reaction with chlorine at room temperature, two organic products are formed. You have to state the condition required. Okay, so the condition required, you will be knowing for this reaction we need ultraviolet light, or we can say UV light. You can say ultraviolet light or UV light. All right. Now next, when propane react with chlorine, let me write the equation for you on the top, then we'll fill that. So propane is CH3, CH2, CH3. It is reacting with chlorine in the presence of UV light. So actually what will happen, one of the hydrogen will get replaced by chlorine. So it's going to be CH3, CH2, CH2Cl plus HCl. So the structural formula, the organic product, you will be writing, this is the organic product, okay, this one. So you will be writing this formula there. So structural formula of the product 1 is going to be CH3, CH2, CH2 and Cl. And the name of this product is going to be, numbering will begin from this end, because there are 3 carbon and we put number only on carbon atom. So it's going to be 1-chloropropane, because chlorine is coming on the number 1 carbon, so we have to say 1-chloropropane. Even you can say if you have to have monosubstitution halogen or alkane, so what you can do, there is something called isomers. If you want to make different isomer, what you can do, you can even replace the hydrogen atom on the second carbon. So if you want to replace on the second carbon, the name of this compound will change. Now let me draw the structure for you. So it will be, just put this chlorine on the second carbon. So it's going to be CH3, CH, you can write Cl, because this Cl is connected to second carbon, and the third carbon will have 3H. So the name of this compound, this time, numbering you can begin from the right or the left side, any side. So 1, 2, 3. This time chlorine is coming in second carbon, so the name of this compound is going to be 2-chloropropane. All right. Okay, now last question for today. The two products formed are structural isomer of each other. You have to just define the term structural isomers. Okay, so the organic compounds or the compounds having same molecular formula but different structural formula. So the organic compound which are having same molecular formula but different structural formula, they are called isomers or structural isomers. Okay, let's see if there are some other question left over. So students, this is about an ester. It's very common question. So you have to name an ester. You know, when you want to name an ester, you have to name this part. This part of the ester is coming from alcohol, right? And this part you have to say this will be the first part of the name. Okay, so this will be first part of the name, and the blue one I can use this color. So this part will come from carboxylic acid. Okay, the blue one. This part will come from carboxylic acid, and it will be the second part of the name. So whenever you say an ester, you have to say like the esters are always named this way. Let me write for you here. So they will be called alkyl alkanoate. So the alkyl part will come from alcohol from this side, and the alkanoate part will come from the left side. Okay, so the name of this ester, you can see on the right side there are two carbons, so we will say ethyl. So the name of this ester is going to be ethyl. As you can see, there are two carbons on this side, and left side how many carbons are there? 1 2 3 4. So butanoate, ethyl butanoate. Okay students, so we have to first name the right part of the ester, and then we have to name the left part. The name of this ester is ethyl butanoate. All right, now we have to work out the empirical formula of the compound E. Okay, so to work out the empirical formula, what we can do first, we can work out the molecular formula. Okay, that I can do for you here. So we can count total carbon in this ester: 1 2 3 4 5 6. So C6. Now we can count H, 3 5 7 9 and 12. Okay, so H12, and there are two oxygen, so it's going to be O2, right? So the molecular formula of this ester is C6 H12O2. And you can see, in order to make a simplest whole number ratio, what you can do, divide them by 2. So it will be 2 1 the 2, so 2 6 the 12, and 2 3 the 6. So this simplest ratio formula is called the empirical formula. Okay, so empirical formula of this ester is going to be C3 H6O1. Okay, so this is the empirical formula for this ester, right? So to make an empirical formula, what you can do, first of all, work out the molecular formula and just get the simplest whole number ratio. Okay, now for the next question, compound E, which is an ester. Compound E is produced when two different compounds react together in the presence of the catalyst. I told you already, the right part of the ester is coming from an alcohol. So which alcohol it will require, because you can see there we need to have two carbon in that alcohol, so it will be ethanol. Okay, so the alcohol part will come from ethanol, the red one. And you can see the left part is coming from carboxylic acid. So which carboxylic acid? That carboxylic acid should have 4 carbon, right? So that carboxylic acid is going to be butanoic acid. As you will be knowing, butane means 4 carbon, so butanoic acid. Okay, now let me write answer for you there. So one is ethanol and the other one is butanoic acid. All right, now they're asking you catalyst. So for this suitable catalyst, sulfuric acid. Or you can say H2SO4, but just name the catalyst. Okay, all right. Now they are asking you the number of unbranched isomers which are having this formula. Okay, C5H10O2. Okay, so when you want to make an ester, you know, we need to have this this linkage is called an ester linkage. Okay, so now let me quickly draw for you all of them. So you are having 5 carbon in the first one. You can keep 2 carbon on this side, 3 on this side, and 1 on this side. So this is the first ester, right? Okay, so this is the first one. Now the second ester you can do this way: COO single bond O. Now you can keep 2 on this side and you can keep 2 on this side, right? This is the second ester which is possible. For the third one, what you can do, see, look at this one, HCOO, you can have methanoic acid, and all the carbon you keep on the right side. So this is the third one. Okay, all right. Now last one. You can, last ester, what you can do, C double bond O, single bond O, just keep 1 carbon on this side and remaining all you keep on this side. So as you can see, I drew all the possible isomers for them. So there are total of 4 isomers. Okay, branch isomers are obviously possible, but unbranched isomer only 4 are there. Okay, these are the 4 possibility of this ester. Okay. Now last question. Let me erase it for you. You need to write the equation for complete combustion of this ester, right? Okay. So as you will be knowing, when there is a complete combustion, you will be getting carbon dioxide and water. Okay. Now let me write the equation for you. So you will have C5H10O2. Combustion required oxygen, so you will have O2, oxygen. It will get you carbon dioxide and plus it will get you water, right? So firstly we have to balance carbon, so you have to put 5 over there because there are 5 carbon. Hydrogen are 10 on this side, so you have to put 5 over here to balance the number of oxygen, number of hydrogen, because 10 hydrogen on the right side. Now you can see 5 to the 10 and 5 15 oxygen on the right side, so it will be 6.5 because you can have now 6.5 here, okay, to make it. And in IGCSE usually they are not, in A level these fractions are allowed in the equation, but in IGCSE you should be avoiding this fraction or like 0.5. So if you want to remove this 0.5 in the equation, what you can do, multiply the whole equation by 2, right? So you have to multiply this full equation by 2. Why me multiply by 2? To make it a whole number. So it's going to be everything will get double, 2C5H10O2 plus 6.5 into 2 will get you 13 O2. It will get you 10 CO2 plus 10 H2O. Okay, so this is the final equation. All right. So basically whenever you are having complete combustion, the products are going to be carbon dioxide and water. And after balancing carbon, first you have to balance carbon, then you have to balance hydrogen. In the end you can balance oxygen. And if you get fraction number or decimal point number, you have to multiply everything by 2 to make it a whole number, right? Okay, I think with this question we are going to end this paper. I hope everything in this paper is clear. And until next time, inshallah, if there are any suggestions, please let me know, and I will keep updating you on my channel. Please like and subscribe my channel, and I will keep on posting more papers for you for the IGCSE exam. Thank you.